to go over those couple of problems that I skipped during the notes. Had a little brain freeze and just want to go ahead and go through those. So horizontal and vertical dilations, if it's a horizontal dilation, it might look something like log base 2 of 2x, and that would be a horizontal dilation by a factor of 1/2. Oof. Okay, so that means that our x's are going to get multiplied by 1/2. So instead of this happening at 1, it'll happen at 1/2. Instead of this happening at 2, it'll happen at 1. Instead of this happening at, let's see, 2, 3, 4. So instead of this happening at 4, it'll happen at 2. Okay, and so you can see it getting done in half the time. Like 10 is usually a good one, so that would happen at 5. Okay, so it'll be there at 5. So we see it getting it done in half the time. Okay, like a basic sketch like that. Not pretty, a basic. Okay, and let me get another color up here so we can look at a vertical one. So then if we want to do a vertical dilation, that might look like 2 times log base 2 of x, and that means our y's would just get multiplied by 2. And so that would be, so instead of 0 times 2, with our y value of 0, 0 times 2 is still 0, so that point will be anchored there. Woo. Rogue blue lines. And then instead of happening at 1, this will happen up at 2. Instead of happening at 2, this will happen up at 4. And so we would have that basic one stretched by a factor of 2. Okay, so those would be those basic transformations. And when I was looking at the key there, I just didn't realize they were showing both in the same problem. So I just had a little brain freeze there when I didn't understand what I was looking at on their end. Okay, and then let's go ahead and take a look at on our table, when we were looking at tables and trying to do the logarithms, and they told us that they were logarithmic. Okay, so we did find on the first two where it was obviously, we could see that it was logarithmic, and we could figure out what the k values needed to be. It was this third one that kind of threw me for a loop for just a second. Now remember, this is the inverse of exponential. So when we don't see that multiplicative change on the input values, when it looks like it's just +1, and then it looks like it's just +2, okay, plus whatever, okay, then we have to look to see if we can see it in the second step. So can we see what it would be in the second step? So like here, this would be times 2, and so this would have to be times 2, which means this would have to be plus 2 times 2 would be 4, so that would have had to be +4 there. And then if it was times 2 again, then that would have to be +8 there. And so 7 plus 4 is 11, and 11 plus 8 is 19. So k here equals 11. Okay, and that's the way I did it my first time through. Now, another way to do it, like when we were doing exponentials and you were trying to figure out how do you get these values, from the x values, which are then proportionally, then change proportionally. And so how would I get from 4 to 1? So that would be 4 minus 3 would equal 1. 5 minus 3 would equal 2. 7 minus 3 would equal 4. And 11, that's our k value that we just figured out, minus 3 would equal 8. So the change there is x minus 3. It's the x minus 3. If we were looking for the vertical translation, or this time it would be a horizontal translation because it's the x values that are shifting to create that. But when we were looking at it on an exponential, it was the y values. And so that's when it was a vertical translation on the exponential functions, but this would be a horizontal translation on the logarithmic functions. But they are still logarithmic. So it can have that same kind of translation to look for. So I wanted to show you that one for sure. For sure, we wanted to practice that. Now, the fourth one, we just didn't even attempt. It's actually pretty easy. These do change multiplicatively. So our outputs are changing additively. They're just adding 7 every time. And our inputs are changing multiplicatively. So remember, when we multiply like bases, we add exponents. So what exponent do I need to add to -2 to get an exponent of 1? Remember, when no exponent is written, it's a 1. That would just have to be e cubed. And so if I do times e cubed again, and times e cubed again, and times e cubed again. Okay, so multiply like bases, add exponents. That means k equals e to the 4th. Which if I add exponents again, I would get e to the 7th, and add 3 again, and I would get e to the 10th. And so that is multiplying by e cubed every time. And so k here equals e to the 4th. And that's what we were looking for. Okay, hope that helps. Finish up your notes. Good luck on your practice. Come with your questions next time.